All right, guys, so this is the review for quiz 7. We will be revisiting inverse with one of these lovely questions with x in 2 places. So when you switch x and y, you get x equals 3y minus 7 over 2y plus 1. Who remembers how we do this? I did that. Now what? How do you do that? Okay. So how do you want me to write that? What? No, there's a whole bunch of steps in the middle you're missing here. Okay, we have to cross multiply. So you want me to do this way first? Okay, that will be 2x, 2xy plus x. I distributed this way. Is that all right? Equals 1 times 3y minus 7 will be 3y minus 7. Now what? Okay, can we do that yet? Okay, so 2xy minus the 3y over to this side and subtract the x back this way. Too much? We good or not? You definitely can do this in different ways and still get the right answer as far as moving things to different sides. All right, now what? Factor out the y over here, and I will have y times I'm taking this one right here. I know this is a hot mess because I went over here and then down and then back over here. 2x minus 3. And over here I'll have a negative x minus 7, which I then have to divide by the quantity 2x minus 3. So my inverse function, which you do not have to write with this notation if you don't want to, is this, negative x minus 7 over 2x minus 3. There are other ways to write that are equivalent. If you want more practice on that stuff, in the chapter 1 packet, there's a worksheet 12 that had it on it, and 13b, that's where we did it the first time. There's also remediation in the bucket on 1.7, and on the back of the remediation worksheet, there's a bunch of these kind. All right, what does it mean for a function to be one-to-one? Okay. Horizontal line test and vertical line test. And what does it mean that it's one-to-one? For a function to be one-to-one like this would mean what? Oh, whoa. We were supposed to be talking about this guy right here. This little bitty graph right here. Is he one-to-one? Yes. Okay. Why is because he passes the horizontal and vertical line test, and what does that mean? Yes. Good job. All right, do I happen to have any of this on another slide? Oh, look, had it more spread out all the time. Okay, so this number 3, we're supposed to graph the original function. This is really tiny graph paper. 1, 2, 3, 4, 5, 6, up to and over 1. Okay. Yeah, that's straight. Squint hard, maybe. All right, how do we find the inverse of that? Right now it says y equals 2x minus 6, so we make it say x equals 2y minus 6. Add 6 over to the other side. Divide everything by 2. We can write x plus 6 over 2, or what would that be? 1/2 x plus 3. Yep, the 2 divides into both. Either one of those is fine for writing on the blank up here. I don't care. But when you go to graph it, even if you're not sure, remember all the ordered pairs should switch, right? So the intercept down here that was 0, -6 now becomes -6, 0. Or you can just graph it by starting up here at 3, going up 1 and over 2, or down 1 and back 2. And it should be the reflection across this line. Pretty close, considering how badly I graph on this thing. Any questions about that? All right, so 1.7 is a 5 all the way around this time. The next one is 2.1. And we kind of had a hot mess last time with this because we had some end behaviors that approached 0. Do you remember last time it looked like this? It was a power function. And we forgot like increasing, decreasing. We didn't do so well. All right, this particular one is a little funky to type in. There's an easier way, in my opinion. We could type it in with a to the 2/3 power. But the way it's currently written, you would type -2, then go to math and pick cubed root, which is number 4, and then type the quantity x minus 1 squared. So it looks like that. I'm going to do a zoom 6. Okay. So does anyone look at this and see what would make this 0? If we put a 1 in here, we'd get 0, right? That's why it's touching here. All right. How would we find the y-intercept? Yeah, we'd go trace 0. Good call. And it's touching down here at -2. Crossing the y down here at -2. Other than that, I'm not really picky about the graph. Okay. So domain, left to right. Guys, I'm really frustrated that we're still messing this up. Domain, left to right. Range, bottom to top. Any questions? This is y values. This is x values. x-intercept, there's huge discussion because some books say this is not actually an intercept because it's what's called a cusp point because there's a sharp turn there, but it is a 0, so I would say we should put 1, 0. The y-intercept was 0, -2. If it's a decimal on the quiz, it's okay to just put the decimal. I'm not going to worry about exact. Dominic, give a question. Did you do a Zoom 6? Okay. Can someone check if... Tell me about end behavior, guys, and then I'll come look. F of x approaches what as x approaches what? What is y doing on both ends, guys? It's going down. So the y's are going down on both ends. And then we can say as we go to the left or the right, whichever one you want to do first. Usually we do. Yeah, we usually do that, right? Left first and then right. Is this continuous? Can you trace this out without lifting your pencil? Yes. Did you get it, Dominic, or do you need me to come look at it? Okay. All right. Part of that same section, though, guys, is solving these. Okay, I'm going to go kind of quick because we did these on Friday. Square both sides, but the left or the right one is got to be, yes. So we get 25 minus 3x equals, okay. Everybody okay with where the 2x came from and everything? Next, we need to, because it is a squared, get it equal to 0. So if I subtract 25 and 3, add 3x, I'll have x squared plus 5x minus 24. Did I do that right? X plus 8x minus 3. Is that right? So I get x equals, okay. If I go to check those, I promise something's going to be extraneous tomorrow, I think. Okay. If I put a -8 in, this will become square root of 49 equals -8 plus 1. Whoops, plus 1. Is that true? Why not? Yep. Okay. If I put a 3 in, I get square root of 16 equals 3 plus 1. That works, right? All right, what happens if I square both sides on number 6? Yes, which one's messy? All right, so square root of x times square root of x is x. Five square roots of x plus another 5 square roots of x would be 10 square roots of x. Can I do it that quickly? 5 times 5 is plus 25. The right-hand side is just x plus 29. Now what? We have to isolate the square root again. Yes, good job. So I have 10 square roots of x equals what? So I could divide the 10 right now, which is 2/5, right? But what do I have to do to find x? It's just reduce. So if I square both sides, I get what? Okay, is that going to reduce? No, be careful. Square rooting and reducing fraction aren't the same thing. So now we could go back and plug it in. Square root of 4 over 25 equals, or plus 5 equals, over here we'd have the square root of 4 over 25 plus 29. All right, this is going to be 2/5 plus 5. And this side is going to be, I'm just going to do it on my calculator, 29 plus 4 divided by 25, math, enter, enter, is 729 over 25, which if I square root is 27 fifths, is 5 plus 2 divided by 5, 27 fifths. Yes, these are equal. Okay. Just messy calculator check. All right. Quickly moving on to the newer stuff. By the way, more practice on this stuff. You can go back and look at summative 6, worksheet 2, or chapter 2, worksheet 8B had some of those, which was on the homework check. All right. There are extra practice like these on 16A, by the way, which is at the end of the current packet. All right, how do we figure out what degree this mess is? You can FOIL it out, but kind of ignoring all the plus or minus stuff, or you could list all the zeros and add up all the multiplicities. Dominic, please. Does this 2 do anything up front? No, it's not a 0. It's a stretch, but it's not a 0. But there is a 0 here of multiplicity what? Multiplicity 2. Okay, then there's a 0 at 2, multiplicity 3. Then there's a 0 at -1, and that's multiplicity 1. You don't have to write the multiplicity 1 down if you don't want. But if you add up all the multiplicity, you should get the degree. Multiplicity 1, multiplicity 3, multiplicity 2. Does that check if we went back here and said I had a 2 with an x squared? This, if I cubed the disaster, would be an x cubed, and this was an x. Does that come out x to the 6th? Okay, so 2x to the 6th, if we ignore all the adding and subtracting, the degree is 6, the leading coefficient is 2. So what does that tell us about the end behavior? Even degree means both ends go in the same way. What's happening when we have a positive leading coefficient? Both ends are up, okay? I don't know what's happening in the middle, but both ends are up. So I say the y is going up on both the left and the right. Are we good? A positive? No. Even degree with a positive leading coefficient. And yes, you could take time to graph that on your calculator, but it's time not well spent. All right, so we're supposed to state the possible number of real zeros. Guys, that means based on degree. What's the possible number of real zeros here? 4. Possible number of turning points is degree minus 1, okay? This was degree. This is degree, if I could write. I'm writing backwards. Degree minus 1. So this is 3. Okay. So factored form. How does this factor? Okay, x squared and x squared minus 4 minus 11. Is that completely factored? This one is the difference of squares, right? So x plus 2, x minus 2, and x squared minus 11 in any order. So where are the exact zeros at? Negative 2, positive 2. You have to, exact means no decimals, guys. So x squared equals 11, x equals plus or minus square root of 11. What does that mean if I graph that? Am I going to see 2 or 4 zeros where it crosses? 4, because those are real numbers, right? No i's. But these two would be ugly decimals if you tried to find them on the calculator. All right. There's a question like this. It doesn't even give you like a graph paper. We don't know what the y scale is. So the y could be going up by, well, it's obviously going up by something big because it says right here, this is 1/300. Okay. But I put the zeros down for you on the quiz. You have to figure it out by looking at the graph paper or the, but where are the zeros? First of all, is this an even or odd degree? It asks. Make sure you're talking about degree. It's even because both ends are going the same way. All right. What are the zeros in the multiplicity? Negative 4, 0, and 5, it says, because it's a little hard to tell on the graph. So we'd have what? Negative 4 would be multiplicity 2. We want lowest we can. It's bouncing there. Okay. Then 0 is multiplicity 1 because it's crossing. And then 5 is multiplicity 1 because it's crossing. You really don't have to write those, but I just want to make sure for your review that you're remembering why this is. Okay, so give me the factored form. Okay, so what can you tell me? X plus 4. What else? X minus 0, or just an X out front, but you're welcome to write X minus 0. I don't care. X minus 5. Okay, something's wrong. Okay, the X plus 4 is a bounce, so it is quantity squared. Make sure you don't put the squared inside, but yes. That's the one that had a bounce. Okay. Now, you have to find the stretch. Who remembers how? Yes, Keaton. Yep, or you could just put it out front. Yep, I already said that, but you're okay. Yes. Yep. We need to find the stretch. Do you remember how to do that? It's why they gave us this point up here, guys. And it's this way on the quiz, okay? You have to go back up here to find the point to put in. So we're going to have 300 equals k times 1 plus 4 squared times 1 minus 0 times 1 minus 5, which will be 300 equals k times 25 times 1 times negative 4, or 300 equals, all of this is negative 100, isn't it? Did anybody get k equals negative 3? Maybe? So I can either go back and put the negative 3 here, or like we've discussed, we could say -3, there was just x minus 0 or an x plus 4 quantity squared and an x minus 5. Is anybody lost on where we got the -3? Okay, I'm moving on. You have to do a regression tomorrow. Quickly type these in, please. Remember how to get to the list? We got to talk about this because you got to be able to turn the scatter plot on and the scatter plot off and find the window because you have to draw the scatter plot tomorrow. We don't have a lot of time here. So stat enter. Please be doing this. I don't have them in yet, do I? Of course not. That'd be too easy. And 20, okay. Where did it go, guys? 70 or 80? Just 70? Anybody read me the other ones? 66 point. 150. Did I mess any of them up? Good. Okay, how do you turn the stat plot on? Because you're going to have to know how to turn it off and on, because if it's not turned off later, you will have trouble with your graphing questions. It's second, y equals to turn it on. Make sure you have list 1 and list 2. Then what? How do you find the window that works so you're not going to see it? Okay, you may want to go into y equals and make sure you don't have other junk in there. Then is zoom 9. Okay, you're going to have to draw a scatter plot on your paper. Now, I tell you tomorrow which one to choose, and I don't think it's power tomorrow, okay? What are the 3 we did? Stat, right arrow. We did quadratic, number 5, cubic, number 6, and power, which is on the next page. It's the one we're doing today for the review. Just choice A. Okay? You are expected to know how to store it. So we're going to scroll down, or just at the end if you have an older calculator. And it's vars, arrow to the right, enter, enter. Okay? I don't care about the regression stuff, but you have to write down the equation. So you would write down to the nearest thousandth, it says on the quiz, so you'd write down 0.042, my bad. 0.042 times x to the power of 1.998. But when you go to predict the car going 80 miles an hour here, you need to use the stored equation. Okay, this is the tricky part because some of you don't have a lot of practice in this. How do we get to set up the table the way we want it? Second window, make sure it's Ask Auto, and then it's second table, and we're putting in 80. So I got 267, and I think tomorrow it asks you to round to the nearest tenth on that final answer. So it, what was it? I already forgot. 267.3 if we round to the nearest tenth. 267.3 feet, I think it is. Yes. Is the stopping distance if you're going 80 miles an hour. Okay. When you're done with this, any questions? Need help? Okay, when you're done with this question, You can turn off your stat plot. So second y equals, actually the easiest thing to do is just go y equals, arrow up, hit enter. Now it says plot 1 is off. You can also go back to second y equals and turn it off. I'm going to clear this out of here. If you want your table to use for values later, you can go back here to second window and turn it on auto. Okay, you don't have to do that, but if you want to use your table later for something. All right, any questions about this? All right, moving on. It says use synthetic division to divide and show work. So what goes in the little box? Do I need any zeros? Placeholders. 3x to the fourth, 2x cubed, but I have no x squareds, right? And then a negative 1x and a 65. Is this the next question? I'm kind of wondering why we didn't do long division next, but we'll get there, I'm sure. Bring this down. Negative 9. Add is negative 7. Multiply is 21. Negative 63. Add is negative 64. Is anybody else getting this disgusting number? 192. I don't know what this is. Somebody help me. 127, 137, 127. Did anyone else get something that disgusting? Yes? Okay, what is the quotient polynomial? This is the remainder. What's supposed to be what? What should this be? Oh, it should be positive there. Okay, gotcha. So it's not going to affect the outcome of my answer in terms of whether it's a divisor. But yes, this should have been 257. Okay. All right, so the quotient polynomial, the 64 is constant, the 21 gets an x, the negative 7 is an x squared, and then there's a 3x cubed out here. That's lovely. Is the x plus 5 a factor? X plus, what? Okay, I'm pretty sure this is supposed to say the same thing here. I'm just changing that to a 3. Is this a factor, guys? Did it go in evenly? You say no, because there was a remainder. Okay, what if the remainder had been 0? Then you would say yes, it is a factor. Went in evenly. Everybody okay? I don't know why that had to be such a long, complicated one. Now we're supposed to do long division. Okay, 4x cubed plus 12x squared plus 3x minus 5. Do I need any placeholders? No, thankfully. 2x squared plus x minus 1. Okay, this looks awful because it's long, but I think because it's what we're dividing by is also big and nasty, it's not going to go in that many times. Okay, 2x needs to become exactly 4x cubed. So I multiply by a 2, just an x, right? But then I have to multiply by everything out here. So 2x times 2x squared is 4x cubed. 2x times x, 2x squared. 2x times negative 1 is negative 2x. And then I'm subtracting, so I'm subtracting this, I'm subtracting this, and I'm subtracting this, which will make it positive. All right, so this is 0. Uh-oh, what happens here? 10x squared plus 5x and a minus 5. Oh, we might be in luck. what happens? 10x squared to become 2x squared to become 10x squared would just need to multiply by 5. And then if I distribute the 5 to all of this out here, I get 10x squared plus 5x minus 5. So when I do the subtraction, this all becomes 0, doesn't it? Okay, so what is the quotient? 2x plus 5. What if I'd ended up with a remainder of 3 or something goofy? Then I'd put plus 3 over all this garbage, right? All right, how do you write a polynomial with real coefficients that have these factors? Factored form. So if there's a 0, what's the factor? X. If there's a plus or minus 3, then there's a factor of plus or minus. Okay, wait. There's 2 zeros, one at positive 3 and one at negative 3. So whichever order you want to write those in. Now, why is there a dot at the end? Because if you have a negative 2i, there automatically has to be a 0 at positive 2i. And you're expected to know that. Now, you're welcome. I did not give you one that says 4 plus I, so you have to put 4 minus I. Do you remember how awful those are to FOIL together? This is much easier, right? It's going to be x plus 2i and x minus 2i. Now, you can't stop here, but it's still not that hard. All you have to do is FOIL these two together because it says you have to have real coefficients in the end. Everything else is real. So final answer, it will have an x plus 3, an x minus 3. But what do we have to do to those two? What will that become? X squared minus 2ix plus 2ix, which will go away, minus 4i squared, which should be what? Yeah, negative 4 times negative 1, which would become plus 4. What if I had written down minus 4? Well, if I wrote down x squared minus 4, I would think, oh, that would factor, right? And it shouldn't factor, or it wouldn't have imaginary solutions, okay? Questions? Handle that one? All right, so that's everything on that standard. Then we have, what is this one? Are we on 2.4? Thank you. All right, so 2.4, it says you can find notes on 6. Assignment is on page 127, and worksheet 8A has more practice on this. All right, when it says list all the possible, do not graph it and tell me only which ones work. You have to list them all. Remember how to do this? Factors of what? All the factors of the constant over the leading coefficient, which is a 3. So what are the factors of 6? Okay. And the factors of the leading coefficient are, okay, you have to tell me plus or minus at some point. You don't have to list it on every one. But then you have to tell me what this means. You can't leave it like this, okay? 1 over 1 would be 1. 2 over 1, 3 over 1, 6 over 1. What else am I missing? Yep, 1 over 3, 2 over 3, 3 over 3 is 1. I don't need to list it again. And 6 over 3 is 2. I don't need to list it again. Okay? And that is 1, 2, 3, 4, 5, 6 numbers. It's actually 12, right? Because they're all positive or negative. All right, so we're going to use that same set of numbers to try to find all the solutions to this. This should say 14. I don't know if I fixed it on your quiz. or on your sheet, but we're supposed to type it in. Okay, what did it say, guys? X to the third? Was it a plain old X to the third? Then what? No, it had a 3 out front, didn't it? Yeah. Okay. 3x to the third minus 4x squared minus 17x plus 6. If I do a standard window, what do you want me to try? Trace -2 looks good. And +3 looks good. We could probably figure out this one too, but it won't help us because it's not a nice one, and we want the factored form with real coefficients. So we found -2 so far. I'm going to put the -2 in the box. What else did we find? Was it +3? Okay, and then there's one more that's probably either 1/3 or 2/3, right? Because it was between 0 and 1. But we should see it at the end of this division. All right, so I have 3, -4, -17. Was it +6, guys? Back here, was this -6 or +6? I can't tell. I wrote over the top of it. It was +6? Okay. Bring this down. So then I get -6, -10, 23, -6, 0. Again, if you don't get a 0 at the end and it's working on the graph, bring it up to me and say, Hofbauer, I know I'm doing something silly. What am I doing wrong? Because I know 1 times 0 is 1 repeatedly, and then it just seems wrong. So just figure out what you're doing. Now, this actually factors, but we also found 3 to be a 0, so I'm going to keep going. Bring down the 3. 9, -1, -3, 0. Okay? What's left as a factor is 3x minus 1, which would make what the 0, guys? 1/3, right? Does that check on the graph? All right. What are we supposed to write at the bottom, though? Do we want the zeros or? Oh, here, you have to do this. This is worth credit. How did we confirm the zeros? We graphed and then we did what? Successive. And I don't even care if you don't say synthetic. No remainders, right? You can write a pretty fancy explanation, but there's my little cheap shot, okay? We graphed it, we did successive division, there was no remainders. That's what that's supposed to say. I don't know what that says. No remainder, okay? So the factored form was x plus 2, x minus 3, and 3x minus 1. You have to be really careful. Please, please, please remember this, okay? If I had wrote x minus 1/3 back here, I would have had to remember to put the 3 out front, yes? The leading coefficient has to be the same. Are we done, or did I miss a whole section? Oh, that was close.